I'm going to talk about Uncle Tom's method for approximating a square root and why it works. So first, when I think about a square root for this video, I'm going to start by thinking about a square. And inside that square, there's a certain amount of area. For this square, let's make it 16. That lets us divide the square into 16 nice small little square boxes. And the square root is just the length of one edge. For this square, you can clearly see that the length of each edge is 4. And we can see that the square root of 16 is 4 because 4 times 4 equals 16. And you can count the boxes, it's pretty clear. So when I think of a square, the square root is just the length of an edge. I don't know why it's called a square's root. Maybe because if you want to grow a square, you have to start with the root and then it grows from there. I don't know. But now let's try and use Uncle Tom's method to estimate something difficult, like the square root of 17. So for the square root of 17, our square is going to be bigger. And the length of each side is going to be a little more than 4. So we're going to call the extra length we have to add, we're going to call that x. So we've got a square with all the same 16 boxes we had in the square root of 16, plus a little more. And so the length of each side will be 4 plus x. And once we figure out what x is, we will have a good estimate for what the square root of 17 is. So first, let's divide our big square into 4 pieces along these yellow lines. And we know that the area of this big box, that's 16, because that's the square root we started with was 4, and 4 times 4, that's 16. And so now we just have to make the rest of this area equal 1. So if we can figure out what x lets this area equal 1, then we will know what the square root of 17 is. Now, it turns out the square root of 17 is an irrational number. So to try and compute it exactly would be irrational. So instead, we're going to make an approximation that gets us really close. It won't be perfect, but you can't get a perfect answer. And the way we're going to pull that off is we're going to ignore this little box in the corner. We're going to ignore that square because if we ignore it, we can figure out the exact value of x that makes the remaining area equal to 1. So with this shape, how do we make those yellow boxes, those yellow rectangles, have an area of 1? Well, let's see how big they are. First, the one on top, that's got a width of 4 and a height of x. And we know that the area of a rectangle is the width times a height. And so the area of that rectangle is 4 times x. The other rectangle on the right has the same area. It has a width of x and a height of 4. So it also has an area of 4 times x. And if we add up the area of the rectangle on top and the one on the right, we'll have a total area of 8 times our mystery number of x. And so we want 8 times x to have an area of 1, because 17 is 1 more than the 16 we started with. And to do that, we're going to set x to 1/8, because 8 times 1/8 equals 1. So our estimate for the square root of 17 is going to be 4 plus 1/8, which is the x that makes that area equal 1. So let's see, how good a job does that do estimating the square root of 17? Well, 4 1/8, that's 4.125 in decimal, and the square root of 17 is 4.1231 ... It's an irrational number, so the numbers go on forever. But you can see that's a pretty good approximation. That's for very little effort. We just took our square root of 4, multiplied it to 2 to get 8, and added 1/8 to our base of 4 because we wanted the area to be 1 more than we started with. So let's try that again, but this time we'll try computing the square root of 18. So the picture is very much the same, but instead of having these two rectangles have an area of 1, we want these two rectangles to have an area of 2, because 18 is 2 more than the 16 squares in the middle. Just like before, the two rectangles have an area of 4 times x and 4 times x. So combined, those two rectangles have an area of 8 times x. And if we want 8x to be equal to 2, well, that'll mean we'll want x to be equal to 2/8 or 1/4. And so our estimate for the square root of 18 is going to be 4 1/4. And you can see it comes really close. 4 1/4 is 4.25, and the actual square root of 18 is 4.2426. Great, that was pretty easy. So we got really good estimates for the square root of 17 and the square root of 18 by starting with the square root of 16 and adding a little bit of space. But what if instead we wanted to estimate the square root of 15? So that's still really close to the square root of 16, but we can't add to 4 to get the square root of 15. Instead, we're going to have to subtract from 4. Turns out the math is the same. The picture's a little bit different, though. So for this picture, we've got the 16 boxes that make the square root of 16, but instead of adding some space, we're going to subtract some space from those sides. So for this side, each edge is going to have a length of 4 minus x. Instead of adding x, we're going to subtract it. And so we have to figure out what x we can subtract from 4 that will make this have an area of 15. Well, just like before, 15 is also the square root of 15 is also an irrational number, and so we can't compute it exactly. Instead, we'll try something rational and make an approximation to that. Just like before, our strategy is going to be to ignore this little box in the corner, because if we ignore that box, we can figure out the exact number that will make the area of this shape 15. Though this is a little bit different because instead of ignoring it and not counting the box, instead we're going to actually count the box twice. We're going to look at the rectangle on top, and that has an area of 4 times x, just like before. And the rectangle on the right also has an area of 4 times x, just like before. But those two rectangles both have that box in them. So we end up counting that box twice, which as long as that box is really small, which it is here, that small error won't make us miss by much. We'll get a number which is a little bit too high, but it'll, again, just like the square root of 17, be very close approximation to the square root of 15. So to make the area of the yellow rectangles equal 1, we're going to, just like before, pick an x of 1/8, because 8 times 1/8 will get 1. And from that, we're going to take 1/8 away from 4, and so 4 minus an 8, that's 3 7/8. That's how much less than 4 we want, because we're going from 16 down to 15, so just 1/8 should do it. And if you check the math, 3 7/8 is 3.875. The actual square root of 15 is 3.8729 ... And that's it. That's why Uncle Tom's method of square root approximation works. And it's a really quick, simple way to get a good guess as to what a square root is going to be very quickly. This was taught to me by my Uncle Tom when I was probably around 9. I hadn't had algebra yet, and was pretty new to math, but I knew what a square root was, and he showed it to me, and I thought it was kind of cool. And it gave a pretty good estimate for what a square root was pretty quickly. And it's kind of a fun trick.